Hi, I'm Zoe, and I'm going to be stepping you through the AP Calculus BC 2014 FRQ question number 2. The question starts off with, the graphs of the polar curve r equals 3 and r equals 3 minus 2 sine 2 theta are shown in the figure for theta is greater than 0 and less than pi. Part A says, let R be the shaded region that is inside the graph of r equals 3 and inside the graph of r equals 3 minus 2 sine 2 theta. Find the area of R. If we look at the picture, we can see that the two equations intersect at x equals 0. So that is going to indicate to us that we need to split up this area into two separate parts. If we look at the left side, we could go through creating an integral and solving through that, or we can just notice that it is a quarter circle with a radius of 3. So then we can just start by adding that portion of the area to our total area. Since the area of a circle is pi r squared and it's a fourth of a circle, it's going to be 9 pi over 4. Then we're going to add the second part of our integral. We're always going to start with a 1/2 out in front, and then our integral. We're going to start at 0 because that is where the region begins, and then go to pi over 2 because that is where the two parts of the regions intersect. Then, since we're only looking at the part that's inside the 3 minus 2 sine of 2 theta function, we're going to square that function. So 3 minus 2 sine 2 theta squared d theta. Then we can just plug that into our calculator and we will get 9.708. Always round to 3 decimal places. Box your answers. And in this case, it could also be rounded down to 9.707, and College Board will take either answer. Part B says, for the curve r equals 3 minus 2 sine 2 theta, find the value of dx d theta at theta equals pi over 6. What we're going to do now, since we know that x equals r cosine theta and our r is equal to 3 minus 2 sine 2 theta, our x is going to be 3 minus 2 sine 2 theta times cosine theta. The good news about this problem is that with your graphing calculator, you can just take the derivative of dx d theta and evaluate it at x equals pi over 6. And it'll give you the answer negative 2.366. That's your final answer. It's always good to make sure you know how to use your calculator, and then you can take shortcuts instead of having to solve the whole thing and do product rule. You can instead just plug it all into your calculator and it will do the math for you, which can help in time crunches. Part C asks, the distance between the two curves changes for theta is greater than 0 and less than pi over 2. Find the rate at which the distance between the two curves is changing with respect to theta when theta equals pi over 3. Now, we first have to look and see what our distance is between the two curves. And in this case, it's just going to be one function minus the other function. And it will be r equals 3, and then r equals 3 minus 2 sine 2 theta. In this case, because it's asking when theta is greater than 0 and less than pi over 2, we can see that r equals 3 totally encompasses r equals 3 minus 2 sine 2 theta. So our distance between the two is going to be 3 minus 2 sine 2 theta. The 3's will cancel out, and we will end up with positive 2 sine 2 theta. This is another one that we can just plug into our calculator again to get the derivative of the distance with respect to theta, and evaluate it at x equals pi over 3, and it'll give us the answer -2. If the question were to ask from pi over 2 to pi, then we would flip these around, because we would see that in that case the 3 minus 2 sine 2 theta completely encompasses the r equals 3 instead of the other way around. Part D asks, a particle is moving along the curve r equals 3 minus 2 sine 2 theta so that d theta over dt is equal to 3 for all times where t is greater than or equal to 0. Find the value of dr over dt at theta equals pi over 6. In this question you have to pay attention because they're asking for dr over dt. However, if we were to take the derivative of our r, it would be in respect to theta, which is not equal. But they also give us d theta over dt, so if we can multiply these two derivatives, the d thetas will cancel out and it will give us our dr over dt. We can evaluate the derivative of r with respect to theta on our calculator, and that'll give us -2. And it gives us d theta over dt, which is 3. So if we were to multiply the two, then we will get -6 as our answer.